Hello, Year 12s. Hello, Year 12s. Today we're going to look at seasonal indices. And seasonal indices are a way that we can adjust for the fact that some time series data is seasonal. So, for example, if you look at sales from an ice cream stand and you take it over just before summer starts, you might say to your manager after 3 months, look, I've done epically. The sales under my 3 months are so much higher than the previous 3 months. And that wouldn't be fair at all, because in the ice cream stand in summer, you expect to sell far more than in winter. So one way you could do it, you could compare it to the previous summer, or you could use seasonal indices to take the effect of seasons out of the data. And if you take the effect of seasons out of the data, you can then compare a summer with a winter. So right now, through this video, we're going to look at how to calculate seasonal indices and what they mean, and then how to use seasonal indices to de-seasonalize data, or to take the effect of the season out of data. Alright, so seasonal indices are calculated so their average is 1. If there are 3 seasons in a year for some reason, then their sum of their indices is 3. If there are monthly seasons, then their sum will be 12. Seasonal indices tells us how much that particular season, or how that particular season compares to the average season. Alright, calculating a seasonal index. You get a seasonal index by doing the value for the season divided by the seasonal average. So here we have, let's say, for example, ice cream sales, because the example we've been going with. Not ice cream sales. Hot chocolate sales, because they're high in winter. Hot chocolate sales. And we want to work out the seasonal average. Now, the seasonal average for us is just the average for each season. So we add them all together and divide by 4. Give me 1 second to do that. So our seasonal average season is 923. That means that on average, each season we sell 923 hot chocolates. So there. Now, the seasonal index for each one can be calculated by the value for that particular season divided by the seasonal average. So for summer, it would be 920 divided by the seasonal average of 923, which equals that. Autumn would be 1085 divided by the seasonal average. Oops. Equal space. Winter would be 1241 divided by 923. And spring is 446 divided by 923. Now, what these numbers say is, they're here, how each season relates to the average. So you might notice that, for example, autumn was above average. So 1085 is above average. Therefore, the seasonal index for autumn will be above 1. Will be 1.176. What this means is that the seasonal index for autumn is 17.6% above average. Or if you take the average and multiply it by 1.176, you'll get autumn's index. And these are called the seasonal indices. Seasonal indices tell us how much better or worse that season was. So for some reason in spring, we only sell 48% of the hot chocolates we would do in an average season. In winter, unsurprisingly, we are 34% above what we would do in an average season. So yes, there's a sentence you can write down. Alright, now seasonal indices are interesting, but their most powerful use is to de-seasonalize data. So just copy these down for now. A de-seasonalized figure is the actual figure divided by the seasonal index. Re-seasonalizing data is, well, you can get the actual figure by taking the de-seasonalized figure and multiplying it by the actual index. These two equations are clearly actually the same equation. They've just been rearranged to help. Alright. Now this will be our big example for it, and I realize it will be slightly painful because these calculations are normally done with, well, an Excel spreadsheet to make it quickly, or your calculator. So, unemployment figures have been collected over a 5-year period and presented in this table. It is difficult to see any trends other than seasonal ones. Alright, now let's just have a quick look at that. If we put in the calculator, we have original data, numbers down here, month number down there. Sorry for doing them the wrong way around. Normally you put month number first, but it doesn't really matter because on our graph we can have month number or original data. And clearly it's chaotic here. We're not really sure of a trend. You can sort of feel there's an upwards thing happening, but you're not entirely sure. If you want to, you can connect the data points. And yeah, you can see there's some seasonal indices happening, seasonality happening, but it's hard to see a trend. Alright, so what we're going to do is calculate the seasonal indices, then deseasonalize the data using the seasonal indices, then plot the original data against the deseasonalized data, and make a comment. So here we're going to essentially work through to take out the effect of seasons. And here's our original data. So against month 1 on my graph was there. 2, 3, 4, 5, 6, etc. Alright, now to calculate the seasonal indices, you may recall from up here, we do the value for the season divided by the seasonal average. So, first thing we do here is work out the seasonal average, or the average for each year. So here, we're working out we're working out the averages for 2005, which is that there, and so on until we get the averages for all 4 of them. Time consuming, I'll show you how to do it in the calculator in a sec. Alright, so then what we do is we divide each term in this original series by its yearly average. So we do summer of 05, we do that summer divided by its yearly average until we get this. So we've done the summer's actual value divided by 2005's seasonal average. So, and then that gives us the seasonal indice for summer 2005. Seasonal indice for summer 2006, seasonal indice for summer 2007, and then we take the average of the seasonal indices to determine the overall seasonal index. Go through that again because it was slightly convoluted. Alright, so what we do is we find the average for 2005. Average for 2005 is 7.37. We then take summer of 2005, divide it by that to get this number 0.84. And we do this for every single data term. That divided by that to get this, etc. And then we can essentially regenerate our data set like this. And set up like that, we can then try and find the average for each season. It's the average seasonal index for each season. We found the seasonal indices for each year. Now we find the average seasonal indice, which is the average of them for summer, gets us that. The average of these for winter, or for spring rather, gets us that. Until finally, we get out the seasonal index for each one. Now note, their average should be 1, and they should add together to equal 4. Alright, now, second question was, deseasonalize the data using the seasonal indices. And from our equation above, we can find a deseasonalized figure by doing the actual figure from the data divided by the seasonal index. What we've done here is we've found the seasonal indices. So to deseasonalize the data, we do summer of 05 divided by the seasonal index of 05. The summer of 05 was 6.2. We divided by the seasonal index of summer to get this number here. So that we go through and do it to all of them, deseasonalizing the data. This here is the deseasonalized data. Alright, now let's go through how to do that on the CAS. And yes, I do encourage you to copy these in, all of them previously, into your reference books. Don't copy them in, print them out and stick them in. Alright, and then we'll go through how to do it on CAS. Alright, now this is going to be quite painful and convoluted, but the good news is you'll rarely be asked to, well, it's very unlikely you'll be asked to deseasonalize an entire pile of data. you're more likely to be asked to either interpret what's happening or to be able to jump in at a stage that they've left off during a question. All right, but let's say we did have to do the entire thing. First thing we want to do is find the year average. So the first year is, I know called the month number, but really they're season numbers, 1, 2, 3, 4. This is the first year. And I want to find the average of the first year. So let's do equals A1 plus B1, A2 rather, plus A3 plus A4 divided by 4. Alright, so that is the average of the first year, 6.9. And we can go back here and look at where that appeared for our first time. We looked at our average for our first year. Okay, I made a mistake before. Fix it now. I put in A1 twice. Alright, 7.37. Sorry, go back here. 7.37. Now, we can drag this down through all our data. God. Come on. But we're not interested really in every number. We're only really interested in every 8th number. So I don't want 5 or 6, but I am interested in that one. And I don't want 9, 10, or 11, but I do am interested in 12, because 12 is the average for year 3. So 7.525, go to here, there's the 7.525 for year 3. And we keep going down. Alright, and there we have our yearly averages. And then on to the next step. The next step is dividing each original amount, dividing it by the yearly average. So I've titled this original div average. So to get this, we would do that. And then over, honestly, easiest way is just to type it in, 7.375. And if we drag that down here, that gets us each one of the first 4 divided by its yearly average. However, that doesn't, of course, do us for the rest, because we're after here, we want the next 4. So equals A5 divided by 7.575. And we do that for the next 4. Oh my goodness. Hallelujah. Once again, they should all add to 4. Right, I'm going to pause it and do the rest of them, and I'll be back in a sec. Alright, now, done for the whole year, we calculate the seasonal indices. Now, the seasonal indices of summer, which is our first month, better be summer, yep, will be the averages of every summer that appears here. So what we're looking for here is equals A1 plus A5, they're the 2 summers, plus another summer up, A9, plus another 4, 13, plus A17. So they are our 5 summers, and we're dividing by 5. That should be the seasonal index for summer. Actually, scratch that. Let's have a look at where I made a mistake, because I'm not recording this whole thing, so I'll just explain the mistake to you. I've said summer is on periods 1, 5, 9. So let's have a look at where that actually falls. 1, that's summer. 2, 3, 4, 5, good. 6, 7, 8, 9, good. Apologies, figured it out. I don't want to be talking about A, the original data. I want to be talking about the seasonal indices. So, column D. D1 plus D5 plus D9 plus D13 plus D17 divided by 5. That's better. Now we want that. That's the seasonal index for summer. let's do it for spring, well, the next season in. What are we at? Autumn. Equals D2 plus D6 plus D10 plus D14 plus D18 divided by 5, etc, etc, etc. I'll pause this and come back. Alright, finally, we've calculated the seasonal indices. 1, 2, 3, 4, so 0.86, 1.07, etc. 0.86, 1.07. Takes a while. Honestly, that is quicker than doing it by hand. Don't worry, you won't have to follow this process through every time. You should do it a couple of times to make sure you can do it. And I'm considering writing some sort of program that does it for you. Alright, now we actually need to deseasonalize the data. So to deseasonalize the data, we need to take every summer value and divide it by its seasonal index. So here we take the original, which was A1, and divide it by its seasonal index, which is now E1. And the next summer one's down here, so equals A5 divided by still E1. 9 equals A9 divided by E1, etc. Equals A15 divided by E1. And that would be our last summer. 9, oh god. And I'll do it for all of the others as well, and be back in a sec. Whew. Okay, we finally have our deseasonalized data. Rather epic. Now let's see what that looks like. Looks like on a graph. So there's the original value. If we go menu, plot properties, add Y variables, and we will look at deseasonalized data, we can see that most of the seasonal fluctuations have been removed and that there is a clear increasing trend. So this appears to be a slight upward trend in unemployment. Whew, apologies about that. We'll have to work out a more efficient way to do it. Having said that, this is how people do it.